Hey everyone, we are back for Unit 5, and throughout Unit 5, we're going to talk about triangles. But in this section, Unit 1, we're going to talk about classifying triangles and then using those classifications to solve problems. So let's go take a look at what do we mean by classify. Well, first of all, before we can classify anything, we have to remember what a triangle is. It is a polygon with 3 sides. And it can be classified by sides or by angles. Okay, now, just as a refresher, guys, angles. You can have an acute angle, which means that the measurement is between 0 and 90 degrees, a right angle, which means one angle is exactly 90 degrees, and an obtuse angle, which is between 90 and 180 degrees. So that's just a refresher, okay, to remind you guys of some vocabulary terms, because we're going to use those to be able to classify triangles. Now, I'm going to make sure that my screen is set up. Okay, so guys, right here, when we say that we're going to classify triangles by their sides, that means that we look at the side lengths, okay? So if we have a triangle with no congruent sides, then that is a scalene triangle. Okay, you guys will probably remember some of this vocabulary. Okay, if you have a triangle with at least 2 congruent sides, then it is an isosceles triangle. Okay, and last but not least, if all 3 sides are congruent, then you have an equilateral triangle. Okay, so most of that is refresher, but I want you guys to have it there. Now, I want you guys to notice something right here. This says that an equilateral triangle is also isosceles. That's because, doesn't an equilateral triangle have at least 2 congruent sides? Yes. So, an equilateral triangle is also isosceles. Okay? Now, when we classify a triangle by the angles, okay, what we're looking at is that if you have an acute triangle, okay, in an acute triangle, ladies and gentlemen, all 3 angles must be acute. So all 3 angles must be less than 90 degrees, okay? And if you notice, I can look at this particular triangle right here, and I can see, yep, that's less than 90, that's less than 90, that's less than 90. It is an acute triangle, okay? All right, now we can also have, okay, a right triangle. Now, a right triangle has exactly 1 right angle, okay, 1 right angle. And if you guys will notice, the other 2 angles are acute, okay, the right angle and then 2 acute angles. Okay, you can also have an obtuse triangle. Now, an obtuse triangle, 1 angle has to be obtuse, meaning that 1 angle is greater than 90 degrees. So guys, we can look right up here and see that angle is greater than 90 degrees. The other 2 angles are also going to be acute, right? Acute. Get it? Acute. Oh, they're just acute little angles. Aren't they so cute? Ha ha ha, right? Okay, now, last but not least, guys, I don't know if you've heard of this term before. It's an equiangular, and I cannot say that word, equiangular triangle. And that means that it has 3 congruent angles. Okay, and if you guys will notice in this picture right here, all 3 angles are marked as congruent. Now, what we are going to see, ladies and gentlemen, is that an equiangular triangle is also equilateral. Okay, I'm going to say that again. An equilateral or equiangular triangle is also equilateral, which means an equilateral triangle is also equiangular. Okay, those go both ways. So if you have 3 congruent sides, you're going to have 3 congruent angles, and you're going to have an equilateral and an equiangular triangle. Okay, so let's go and look at some other vocabulary terms on page 2. Okay, and we're going to talk about all these specific terms. Okay, first and foremost, interior angles, guys, because we're going to have interior and exterior angles of triangles. So interior angles are inside the triangle. And if you notice, angles 1, 2, and 3 up here in this picture are inside the triangle. but we also have exterior angles. Now, exterior angles, yes, they are outside the triangle, okay? Exterior angles, and I was going to highlight this right here, form linear pairs, okay, with the interior angles. And they are angles that are created by extending the sides of the triangle. So guys, if I go from this corner right here and I go and I extend that side, do you see that I just made an angle out here, angle number 5? That is an exterior angle, okay? So same thing with angle 6 and angle 4. They are outside of the triangle and they are made when I extend the sides of the triangle. And, okay, I'm going to put this in a different color. Guys, if you see angle 5 and that interior angle that I just drew in, those two angles right there form a linear pair. So this interior angle and this exterior angle must add up to 180. Okay, 180 degrees. Now, that brings us to the triangle sum theorem. Now, you guys have been using this and you didn't even realize it, right? That is, the triangle sum theorem says that the sum of the measures of an angle, of the interior angles of a triangle, are 180 degrees. So if I add up all three angles, angle 7 plus angle 8 plus angle 9, they must add up to 180 degrees. Okay? You guys were using a geometric theorem and you didn't even know it, did you? Okay? All right, now, there is a corollary to that particular theorem, okay? And that says that in a right triangle, and this is only in a right triangle, guys, notice it says the measure of angle 1 plus the measure of angle 2 would equal 90 degrees. So let's test this. If I've got angle 1 plus angle 2, that equals 90 degrees, plus the 90 degrees, oh, well then all three angles add up to 180. Okay, so you guys will notice as we go through the unit that you'll be able to see that if you have a right triangle, angles 1 and 2, you can solve them by finding, hey, they must add up to 90 degrees. Okay, let's take a look. Hey guys, I'm going to do one of the algebra review problems with you today. So let's go down and take a look at letter A. Letter A is an apple. All right, we're down here at letter A. And guys, if you notice, there are some specific instructions this time. No decimals, fraction form, or whole numbers only. Okay, so no decimals means do not put it in your calculator and get a decimal answer. Keep it as a fraction or as a whole number. So what does that look like? Well, let's go in. I'm going to zoom in on letter A here, and we're going to talk about it. Okay, now I'm going to help you guys solve this one. Now, guys, we have a whole number equal to a fraction. Oh, hey, Miss Smith, if we have a number that's equal to a fraction, we can put that number over 1 and then cross multiply. Yes, we can, except for the fact that, guys, we have parentheses in this numerator right here. We need to simplify this first, okay? So we're going to rewrite the expression. So I have 120 over 1 equals, and then I'm going to distribute the 180 times n, which is 180n, minus, because I'm doing 180 times a negative 2, so minus 360 over n. Okay, now, I bet some of you are saying, hey, we can just cancel out that n, the n right here and the n right here. Nope, you can't, guys, because there's no n over here at the 360. So you cannot cancel those out. What we have to do from here is cross multiply. So let's cross multiply. We've got 1 times 180n minus 360. Okay, well, that's going to give us anything times 1 is just going to be itself, equals, and then we're going to cross multiply right here. Okay, the 120 times n. So that equals 120n. And now, guys, now I bet you can solve it. But I'll go ahead and work it through with you guys. Okay? So I need to get the n all by itself. I need to isolate the variable. So I am going to subtract 180n from both sides. Okay, and I bet some of you are going, but Miss Smith, that's going to make the n negative. It's going to be negative 60n. Hey guys, that is okay. Okay, that is all right. Because to get the n by itself and to make it positive, we're going to divide both sides through by negative 60. Okay, so your n is going to equal 360 divided by 60. Well, a negative divided by a negative is a positive, and 360 divided by 60 is 6. So our n equals 6. Okay, so I did that one with you because it was a little bit different. Okay, you guys are going to do the rest of the algebra review on your own during class. But now I'm going to take you down and we're going to do one of the problems where we're going to take, okay, and let me get big up here. We're going to take what we know about classifying triangles and we're going to see, okay, by using the distance formula and the slope formula, what kind of triangle do we have? So guys, go down to number 12 and I'll meet you down there. All right, you guys, so if you look, number 12 takes up this whole page. Well, we're going to work it out little bit at a time, okay? So first of all, I'm going to zoom in and we're going to read the instructions. It says for 11 and 12, you're going to use the length and the slope of the sides of a given triangle to classify it. We're going to classify it by its sides, and then we're going to determine whether or not it is a right triangle. Okay, I want you guys to think back for just a second. Okay, if I have a right triangle, what must be true? That's right. If I have a right triangle, then I'm going to have a right angle. Okay, and if I have a right angle, that means that the slopes of two of my sides must be what? Okay, hopefully you remembered that negative reciprocal slopes create perpendicular lines. So we got to figure out if the slopes, any of the slopes are negative reciprocals, and we need to find the length of the sides in order to classify it by its sides. Is it scalene or isosceles or equilateral? Okay, so let's go take a look. We're going to work this through, okay, one step at a time. All right, so it says right here, for triangle ABC, and it gives us the points. This says right here, this says find the length of AB. Find the length of AB. Okay, so guys, length. Length is the same thing as distance, and we have a formula. Okay, so which formula should we use to find the length of AB? All right, let's see if you are on track. Okay, we are going to use the distance formula. Okay, and I'm going to actually write it right up here. The distance formula equals the square root of, okay, x2 minus x1 squared plus y2 minus y1 squared. Okay, do you guys remember that? All right, so we're going to use this formula and we're going to find the length of AB. So that means that I'm looking at A and B. So I'm going to label my points x1, y1, x2, y2. Oh man, Miss Smith, we've done this before. Yes, you have done this before. And we're going to keep doing it. Okay, so guys, just because we do it once doesn't mean that it goes away. We're going to use these things all year long. Okay, so let's plug in what we know. All right, so the distance equals, we're going to plug in. All right, my x1 and my x2. So my x2 is 6. My x1 is 3. So I have 6 minus 3 squared plus, and my y2 is 9 and my y1 is 3. So I have 9 minus 3, and that whole thing is squared. Okay, and then I'm doing this for you guys as a refresher. Okay, you guys are going to do some others on your own here in just a second. 6 minus 3 is 3. 9 minus 3 is 6. And yes, I'm keeping those in parentheses because remember, if they're negative and I put it in my calculator, I must have it in parentheses before I square it. Okay, so 3 squared is 9. 6 squared is 36. All right, so 9 plus 36 Guys, that equals 45. So, the square root of 45, ladies and gentlemen, that is our exact answer. Right here, this is the exact answer. Okay, so I'm going to compare the lengths of the side using the exact answer. Now, if you put this in your calculator, you could say that it is approximately, and that little symbol right there means approximately 6.7 units. Okay, and right here, this is the approximate value. Okay, this is the approximate value. Okay, so I worked out the length of AB with you. Like I said, to compare, I'm going to use the exact answer, the square root of 45. Okay, now for BC, I want you guys to work out, and I want you to plug in the distance formula, and I want you guys to find the length of BC, and then I want you to tell me, what did you get for the length of BC? Okay, how'd you guys do? Did you get that the length of BC is 12? Oh, hopefully you guys remembered to put the negative in parentheses before you squared it, right? Okay, I'm hoping that you did, because when you square a negative 12 times a negative 12 is a positive 144, and the square root of 144 is 12. Okay, a little bit of practice there. Let's try another one. I want you guys to go find the length of AC and tell me, what do you get for the length of AC? Okay, how'd you do on this one? Okay, did you get that AC is the square root of 45 units? Oh, did you remember to put the negative 6 in parentheses before you squared it? Hopefully you did. Okay, remember, and then when you do that, negative 6 times negative 6 is 36, and 9 plus 9 is the square root of 45. All right, so guys, if we're classifying a triangle by its sides, we have to look at the lengths. And if you guys will notice, we have a length of the square root of 45, a length of 12, and a length of square root of 45. So we have two sides that are congruent. Okay, so how, or I should say, what would be the classification of this triangle by its sides? Okay, remember, by its sides is either scalene, isosceles, or equilateral. Well, which one do we have? We have an isosceles triangle because we have at least two sides that are congruent. Okay, all right, so we're partway through. Okay, partway through. Excuse me. Now, guys, now we need to go find the slopes of these lines. Okay, we need to find the slopes of line, first of all, the slope of line AB, and then the slope of line BC, and then the slope of AC. Okay, now, I am going to remind you guys, okay, that, okay, the slope formula, and I'm going to write this down here first, and I'm going to abbreviate. All right, isosceles, we said we had an isosceles triangle. Okay, slope formula, just as a reminder, and I'm going to write it right here for right now. You guys should write it down. Okay, we have y2 minus y1 over x2 minus x1, right? That is the slope formula. Oh, wait a minute. We just did that, didn't we? We said that we had the x2 and the y2s up here, didn't we? Okay, so right here, this is x2 minus x1, and this is y2 minus y1. Okay, so let's rewrite those. Okay, so y2 minus y1, that would be 9 minus 3 over, and then the x's, okay, would be 6 minus 3. Okay, everybody see where I got that from? Okay, here's the change in our x's, here's the change in our y's. Okay, and guys, you can also go back up to the points up here, can't you? Okay, and you can look at A and B and do the x1, y1s. Okay, so let's go on down here and let's look. Okay, remember, slope. I take the, the rise over the run. Well, 9 minus 3 is 6. 6 minus 3 is 3. And I'm going to leave this as a fraction unless it is an exact whole number. And 6 divided by 3 is 2. But wait a minute. I want to leave it as a fraction because, remember, ladies and gentlemen, we're trying to see okay? Are any of our slopes negative reciprocals, right? Okay, so when we talk about the slope of AB, I'm going to put that it is a positive 2/1. Okay, I'm going to use that slope right there to try to find negative reciprocals. Okay, I did one of the slopes with you guys. I want you to go and find the slope of line BC. Okay, go find that right now. Guys, how'd you do? Okay, so look at my work right up here. Okay, and then look right here, negative 12 divided by 0. Guys, that's an undefined slope. Okay, undefined. Now, when we say undefined, that means that it is a vertical slope, right? Okay, so undefined. We can abbreviate it just like that, undefined slope. All right, let's see. Let's see how you do now. I want you guys to go find the slope of line AC. Go find that slope. Okay, how'd you do on that one? Okay, look at my work, compare it to your work. Okay, you should have gotten that the slope of AC is a negative 2/1. Now, we're going to use these slopes that we have in the boxes right here, and we're going to determine, do we have a right triangle? Okay, what do you guys think? Looking at these slopes, do we have any perpendicular lines up there? All right, hopefully you guys said, no, Miss Smith, there's no perpendicular lines because, okay, right here, I've got positive 2/1, and over here, I've got a negative 2/1. Well, those are negatives of each other, but they're not negative reciprocals, okay? And I'm going to write this in parentheses. If we were to have the negative reciprocal, it would be a positive 1/2. That's not what we have. We don't have that. So we do not have a right triangle. So that goes down, and I'm going to scroll on down on our page right here. That goes down. No, we do not have a right triangle. And the reason why is because, okay, we have no negative reciprocal, and yes, you can abbreviate, because there's no negative reciprocal slopes, okay? Therefore, you have, and these three little dots right here, guys, that means therefore in math language. Therefore, there are no right angles. Okay, no right angles. All right, so guys, we worked through this one, and this one was kind of long, right? But we're taking from what we've learned earlier, and now we're applying it to classifying these triangles. I'm just not giving you the side lengths. You're having to find them, right? I'm not giving you the angle measurements. You have to see, is it a right angle by using the slopes? Now, there are some other types of problems in your assignment that you are going to do, okay? But I have something important to talk to you guys about before you guys get going on this in class. I want you guys to flip back to the very first page of your notes, because there's something I want to point out to you guys. All right, go back to the very first page. All right, so back here on the very first page, I want to point out that when you are classifying triangles, okay, guys, you're going to classify it by its sides and by its angles. So you're going to choose one from up here on the sides and one from down here on the angles. You cannot say that you have an acute right triangle. There is no such thing. Okay? There is no such thing. You can say that you have an acute isosceles triangle. You'll notice that I've got one from the sides and one from the angles down here. But you cannot use two classifications from angles, or you cannot use two classifications from the sides. You can't say you have a scalene isosceles triangle. There's no such thing, right? But you can have a scalene obtuse triangle, okay? A scalene obtuse triangle. Okay, so that's just a little bit of a, I just wanted to cue you guys in on that, okay, before you get started. All right, so guys, we're going to see you in class. You're going to finish this assignment in class. And as always, if you have questions, please ask. See you guys later.